In this tutorial, we will build a football analysis system from scratch. The project detects and tracks players, referees, and football across the whole video using YOLO. So let's get started with this. So over here, you can see that I have created a project in my PyCharm Community Edition over here by the name Football Analysis System. You can also create a project in your local directory as well. So first of all, before we go ahead, I will just create a directory by the name input videos. And over here, I will add an input video. So I will now add an input video over here. So we will be testing our model on this input video. Okay, so I've added a video. Let me show you this video as well. So over here, you can see we have our input videos directory which we have created, and here is the input video that we have added in our project. So if I just click on this over here, so this is a football match video which I'm just showing over here. So you can see that this is a football match video, and we will be using this video to test our model so that whether we are able to detect and track the players, referees, and the football as well. So let's get started with this. So this is a 30 seconds video, and we will be using this video for the testing and analysis purpose as well. Okay. So over here, you can see that we have created a directory, we have added an input video. So going ahead, we will just create a requirements.txt file. So now I will just create a requirements.txt file. In the requirements.txt file, I will add all the packages that are required in this project. So we require the Ultralytics package. We will be using a YOLO11 model. YOLO11 model comes under the Ultralytics package. So we will be using the Ultralytics package, and we will be installing this package. Plus, we will use the Supervision library as well. So Supervision library is available under RoboFlow. So if you just over here, so let me just open the browser and show you about Supervision library. So if I just write over here Supervision. Okay. So over here you can see that uh, the Supervision library is available under RoboFlow, and you can find all the details over here. Okay. So basically, we will be using Supervision library basically to make our UI look better. So we will be creating circles around the detected object instead of bounding boxes. Okay, and we will also create a triangle above the football as well. So to make our UI more attractive and user friendly, or we will be using the Supervision package in this project, but they are different tasks which you can perform using Supervision, and you can find all those details in this README file. You can check out as well. Okay. So these are the two packages which we require over here. So I will just I've now opened the terminal, and let me install all these packages over here. So install these packages. I will just write pip install -r requirements.txt. So we also require the OpenCV Python package, but when you install Ultralytics package, OpenCV Python package also get installed with this as well. So we don't need to install the OpenCV Python package separately. So now you can see that it's installing Ultralytics Supervision package, and you can see that with this OpenCV Python package is also getting installed. Again, a lot of different packages that get installed with the Ultralytics package, including SkyPy, ScenePod, Matplotlib, like so many packages. Like you can see that are also getting installed with the Ultralytics package. Okay, So now what we will do is I will just play with the YOLO11 model. Uh, so let let us get finished with this. So the package installation will take a few more seconds to complete. But before this complete, let me show you the YOLO11 model. So I will just write YOLO11 GitHub. Okay, so here you can see we have the YOLO11 GitHub repository. Okay. Okay, so over here you can find that YOLO11 comes with five different models: YOLO11 Nano, YOLO11 Small, YOLO11 Medium, YOLO11 Large, and YOLO11 Extra Large. YOLO11 Nano is the fastest but it is least accurate, while YOLO11 Extra Large is the most accurate but it is less fast as compared to other YOLO11 models. Currently, YOLO V12 is also available, but YOLO11 currently is more fast as compared to YOLO V12 in terms of analysis which I have performed. So I will prefer using YOLO11. So this is some issue. So in this, so you can see that the package installation is still in progress. I don't have a GPU in my local machine. I only have CPU. So these are some constraints that I need to keep in mind as well. Okay, so if you have an NVIDIA GPU available in your local machine, that is very good and you can use it as well. So first of all, uh, we will create a .py file by the name YOLO Inference .py. And now I will just write the code to do object detection and tracking using YOLO11. And I will be doing using YOLO11 pre-trained model and to detect the players and the football. So and see how our results look like. So we will see if we can complete this task of football analysis using the pre-trained model, or we just need to fine-tune the model on the custom data set. So first of all, we will import all the required libraries. So we only required one library. So first of all, I will just write import all the required libraries. So from Analytics, I will import YOLO. Then I will load the YOLO model, load the YOLO model. So I will just write model is equal to YOLO, and I will be using YOLO 11. We can use the YOLO 11 large model. Okay. So, and first, let's perform object detection. Then in the next part, we'll perform object tracking as well. So I will just write results is equal to model dot predict. In the source, we'll pass the input video path. So I'll just write input videos. So let's write input videos, and we can just pass the path of our input video, which is over here. So we can just write video dot mp4. Okay, we want to save the output video, so we'll just write save is equal to true. Okay, so the package installation is still in progress, so we just need to wait for a few seconds for this to finish so that we can run this and see how it works and how well our results look like, whether we are able to detect the players, sports ball, and how promising our results are. So now I've just written the script. So we will be using Alterytics YOLO11 large pre-trained model to detect player and sports ball or football in this complete video. I'm just waiting for the package installation to finish so that I can run YOLO11 model on this input video. So the package installation is being done. So let's run this .py file. So I will just write Python YOLO Inference .py and let's run it now. So now the complete video will be divided into different frames, and it will our YOLO11 model will perform detection on each of the frame one by one. So we are using YOLO11 large pre-trained model to detect players and sports ball in this video, on the input video, and we will see how our detection results look like. So first you can see that it's downloading YOLO11 large model from the GitHub repository Alterytics. Okay. And after it downloads the model, the processing on the input video will start. And so now you can see the model size is around 49 MB and it's downloaded. So the model is now downloaded. Okay. So So you can see that the complete video is being divided into 750 frames, and it's doing detection on each of the frame one by one. Like you can see over here, we are able to detect the persons which are player, and we are also able to detect the sports ball. So currently the complete video is being divided into 750 frames, and on each of the frame detection is being done. So this processing will take some time. So currently you can see that only 22 frames are processed and we need to process complete 750 frames. So it will take some time to process all those frames. So I will just pause the video and I will be back when the processing on this input video is finished. Like all the 750 frames are processed. So let's wait for the processing to complete and then I will be back. The processing on the input video is completed. So let me show you the output video and see how our results look like. So let me just open the output video. We can just go to runs, detect, predict, and here is our output video. So let me just open this. So over here, you can see that we are able to detect the person, and here you can see we are also able to detect the sports ball as well. Okay. So like you can see over here, we are able to detect the persons, and like we can say these are the players, and we are also able to detect the sports ball. But you can see that only in the starting few frames we are able to detect the sports ball. After that, sports ball is rarely detected. Like uh, with sports ball detection, the results are not promising. Like only at the starting few frames we are able to detect the sports ball, like over here, and after that only able to we are rarely able to detect a sports ball. Like after we are only able to detect a sports ball or football in the starting few frames. After that, sports ball is not detected or it's rarely being detected. So, like we can say that there are few discrepancies in our result. Like first, like we are only able to detect a sports ball in the starting few frames. After that, we are not able to detect the sports ball or the football. Like it's rarely being detected. So these few detections will definitely hit us. And the second discrepancy is that we only want to detect the players inside the football court. Like we don't want to detect these like this person or this person. We only want to detect the players inside this football court. So it will be good if our model can ignore these persons like over here. So we only want to detect the players that are inside this football court. So currently you can see that we are detecting the persons over here and here these two persons as well. So they are outside the football court and we want our model to detect only the player or the person that are inside the football court. We don't want to detect this person. So it would be good. It will be good if our model can ignore these two person and not detect those persons. Plus, like you can see over here, it will be good if our model can differentiate between the referee and the player. Currently, you can see that our model is unable to differentiate between the referee and the player. Like you can see, we have the referee over here, and here we can see we have all the players. Like you can see over here, but our model is unable to differentiate between the referee and the player. Okay, so these are three discrepancies which I have found. Like First is that sports ball is really detected. Sports ball is detected at the starting few frames. After that, sports ball is not detected. But plus, the second discrepancy is that we are detecting the person or players outside the football court. We only want to detect the person or the players that are inside the football court. And the third different discrepancy is that we are unable to differentiate between the referee and the player. So we want our model to differentiate between the referee and the player. Okay. So over here. So before we go ahead, let's see how we can do all this with the object tracking as well. So to implement tracking, so we can simply just write over here model.track, and we can just write over here this is equal to true, so that we are just telling our model that there is a frame coming next as well. So this is a video just telling our model. So instead of predict, we are using track, a function inside Ultralytics, so that we can implement object tracking. So in object tracking, what we do is we assign a unique ID to each of the detected player, and that ID will be assigned to that object or player until that player is in the video frame. So this is what is object tracking. In object tracking, a unique ID is being assigned to each object in the video frame, and that object will retain that unique ID until that object is in the video frame. Okay, so let's run this. Now we will see how does tracking works. Okay, and then we'll proceed further. So the processing will take some time. Like you can see that currently it will first try to auto update the lab library. Okay, so now the processing on the input video will start now. So now you can see that the complete video is being divided into 750 frames, and the detection and each of the frame will be done one by one. So the processing has started. Like you can see that currently it's unable to detect the sports ball. It's only detecting the players as persons. So let's wait for the processing on the input video to finish, and then I will show you the results. And then we'll proceed further and address the three discrepancies which I have highlighted. So let's wait for the processing on this input video to complete. So the processing on the input video is completed and we are able to implement object tracking. And let me show you the output. So let me just open the folder, and here you can see we have the runs detect. Now we have implemented object tracking. So you can see our tracker is being created or folder, and here is our output video, and let me just play it. So now you can see over here, we are able to implement object tracking. In object tracking, what we do is we basically assign a unique ID to each of the detected object. Like you can see over here, a unique ID is being assigned to each object, like an ID of 4, ID 6, like ID 10, and that these object retain that ID until that object is within the frame. Okay, so until that object is within the video frame, that ID will be retained by that object. Okay, so a unique ID is being assigned to each of the detected object over here, like ID 19, ID 566, ID 8, ID 10, ID 18, ID 367. So each object is being assigned a unique ID. So previously we have seen that how we can implement object detection using YOLO11, and now we have seen that how we can implement object tracking using Ultralytics on this input video as well. So as we have discussed that we have found three discrepancies in our results. First of all, in object detection, we were able to detect a sports ball in first few frames, and then we were rarely able to detect a sports ball. But as we implement object tracking, like you can see that in this complete video, we are not able to detect a sports ball in a single frame. Okay, so the sports ball is not being detected. So this is the number one in like discrepancy, that we are not able to detect a sports ball even in the complete video, like not in a single frame we are able to detect the sports ball. Secondly, we only want to detect the player that is inside the football court. We don't want to detect these players, these persons that are outside the football court, like these two persons are outside the football court, and I don't want to detect these persons. I only want to detect the players that are inside the football court. Okay. Plus, second thing is that let me just show. So this is the point number two, that we only want to detect the players that are inside the football court. I don't want to detect these persons that are, like you can see, these two persons are outside the football court. I don't want my model to detect these. Plus, you can see that currently I am unable to differentiate between, like you can see over here, here is our referee. Okay. So currently I'm unable to differentiate between that referee and the player. So I want to differentiate between that referee and player. I want my model to differentiate between the referee and the player. Currently, you can see that the referee is being having the same label person, and the player has the label person and the same color of the bounding box. So currently, we are not able to differentiate between the referee and the player. Okay. So now we need to address these three discrepancies which I have highlighted. Okay, so let's go ahead with this. Let me just close this up now. So if I just open the browser, I have just found this football player detection dataset on RoboFlow. Let me just show you the dataset first. So we have around 372 images in our dataset. And if I just check the dataset, okay, so after applying augmentations on training data, like we have applied four different augmentation approaches on our training data. So after applying augmentation, our training data has increased to 612 images. Now we have in our training data, we have 38 images in the validation data, and we have 13 images in the test set. So over here, now you can see that we have four different classes like ball, goalkeeper, rep player, and referee. So previously we are not able to detect a sports ball. Now we have a class ball. Plus previously we are not able to differentiate between the player and referee. So now we have a separate class for the player and referee. Plus we are also able to differentiate between the player and goalkeeper as well. Okay, so let me just show you this. So now you can see over here. Now you can see. Uh, Let it will just take few seconds. Currently it's a bit blurred. So currently, you can see over here, now you can see that we have the sports ball over here, we have the goalkeeper over here, and now we are able to differentiate between the referee and the player. So we have the referee over here, and here you can see that we have all the players. Okay, so our data set look quite promising now. Okay, so we have the referee over here, we have the player, we have the goalkeeper, and here is our sports ball. Okay, so let's look at some other image as well. So, but here, so it will take a few seconds to load this input image. So here you can see we have the sports ball, we have these players over here, and here you can see we have our referee over here. So this is what we are looking for. Okay, so now I have already prepared a complete notebook for this over here. Okay, so I've already done the training, but I will show you how you can train YOLO11 model on this football player detection data set. Okay, but before running the script, please make sure that you have selected the runtime as T4 GPU. Google Colab offers free GPU for a couple of hours each day, so you can definitely use it to train your models. So currently we are using GPU memory. Okay, so now we will install the alternative package. YOLO11 comes under the alternative package. So if you want to do object detection or train YOLO11 model on any custom dataset, you need to install the alternatives package. Okay, So meanwhile, the package gets installed. So now we just need to export this dataset from RoboFlow into our Google Colab notebook. So we can just go with this version number 1, and we can just click on download dataset. And so we just want to get the code snippet, and using the code snippet, we will download this dataset. So if I just click on download over here, so now we can just copy this code over here, and we can just add this code over here. Okay. So using this code snippet, we'll be able to download this football player detection dataset in our Google Colab notebook. So currently the Alteryx package is getting installed. With Alteryx package, many other packages like Seaborn, Matplotlib, SkyPy, and Pandas, and OpenCV Python, many other packages also get installed along with this as well. Okay. So let's wait for this package installation to be get done. It will take few more seconds, not much time. Or okay, okay. So the package installation is being done. So now we can see if Alteryx package installed and it's working fine or not. Okay. So now you can see that Alteryx is package installed. The latest Alteryx version is installed and setup complete and it's working fine. Okay. So now we'll download this football player detection dataset from RoboFlow into our Google Colab notebook over here. So now first it will download a dataset in zip format. Okay. So if you just see like what this warning is appearing is that because OpenCV Python package is already installed or imported previously in the runtime, and when we install or RoboFlow package or Alteryx package, there occurs like crash between this. So because it's already installed, so you can just skip this. So you can just click on cancel from here, or okay. So then you can just check the dataset location from here. Okay, and now you can just train the model, YOLO11 model on this football player dataset. So I have already trained the model on this football player dataset for 80 epochs, and you can see that we are just getting a mean average square with IOU 0.5 as 0.823, like 82.3%, and mean average precision when IOU varies from 0.5 to 0.95 is 0.6. And here you can see that for each class we are getting the results, and like for only sports ball, the mean average precision is a bit low, but for all the other classes we are getting a very good mean average precision score. Okay, so I have already downloaded these best model weights into my local directory. So let me just switch back to the PyCharm and start writing down the code, and uh, let's test our video on this model weights. Okay, so first of all, I will just create another directory by the name models over here. Okay, and now I will just add the best model weights that I got after training. So I will just add over here. I will just add over here. So I'll just add. So these are the best model weights that I got after the training. Okay, so now what I will do is I will just write model. So I just need to go to the models directory and we'll use this best model weights over here. So let me just run this. So now I will just run on this input video. Okay. And let's see what results we get. So I will just write Python YOLO-inference and start by. Okay. So the processing on input video will start now. Okay. This will take some time. So let's first start processing on this input video. So now you can see the complete video is being divided into 750 frames, and it's doing detection on each of the frame one by one. But now you can see that we are able to detect a football, goalkeeper, referees as well. Like previously, we were not able to detect this football. Plus, previously we are not able to differentiate between the player and the referee. So now you can see that our results look quite good. Like we are able to detect a sports ball. We are able to differentiate between the player and the referee as well. Okay. So like two our offered discrepancies are I think being addressed, but the third discrepancies that or the second discrepancies that we were discussing is that we only want to detect the players inside the football court. We don't want to detect the persons outside the football court. So we'll see in the final output video that if we that works or not. Like we should not be detecting the persons that are outside the football court. So so currently the processing is being done, but I can see that the results look quite promising. Like we are able to detect the football, we are also able to detect the players, plus there are three referees in a football match, and we are able to detect the three referees as well. Okay, so let's wait for the processing on this input to get finished, and then I will show you the output video. So the processing on the input video is being done, and let me show you the output video over here. So if I just go to the predict2 folder and let me just show you the output video. So now over here, you can see that we are able to detect the football. We are able to detect the players. We are also able to detect the referees. The results look very promising. Like you can see over here, we are able to detect a goalkeeper. We are able to detect a football. We are able to detect the referees. And now you can see that results look quite promising. Like almost in all of the frames, we are able to detect a football. Okay, like you can see that results look quite good. Like we are able to differentiate between the player and the referee. Plus, you might have noticed one thing that we are not detecting the player that are outside the football court. Like this, the persons are not detected. Like you can see over here, one, two, three. Like these three persons are not detected as they are outside the football court. So we are not detecting these three persons. And we are only detecting the players that are inside the football court. And we are able to differentiate between the referee and the player. And we are also able to detect the football as well. And detection results look quite promising. So you can see that we are not detecting these three persons that are outside the football court. So one thing that I want is that I don't want these bounding boxes. I want triangles below each player. And for the football, I want to just create a triangle above it. So let me just show you what is in my mind. So if I just go over here while just preparing for this tutorial, let me just show you what I'm thinking. So I want to just generate an output like this. Like you can see over here, like I just want to create a triangle below each player. And here you can see we have a unique ID assigned to each of the player. Like object, we have implemented object tracking. In object tracking, we basically assign a unique ID. So I've assigned a unique ID. And you can see that we are able to differentiate between the player and referee. Like for the referee, we have this yellow color circle. And for the player, we have this red color circle over here. Okay, and for the sports ball, like you can see over here, for the football, we have created a triangle above the football, like you can see over here. Okay, so we have just created a triangle, like you can see a green triangle. You can see over here that we have created above the football. Okay, so and we have just created circles below each player. Okay, and we are differentiated between the referee and the player. Okay, so this is what I want. So let's implement this now. So first of all, I will just create a main.py file over here. Okay, and then I will just go ahead and create another directory by the name utils and create a video-utils.py file. Okay, okay. So first of all, we will import all the required libraries. So I will just import all the required libraries over here. So we only require one library, which is CV2. Then I will just create a video read function. So I'll create a read video function. So we just write define read video. So the input to this function will be the video path, and we'll just write cap is equal to cv2 dot video capture, and the input will be the video path over here. And we will just create an empty list by the name frames, and then I will just write while true. Okay, and then I will just write rect frame is equal to cap dot read. Okay, and I will just write if not read break. Okay, and then I will just append all the frames into this list. Okay, and this will return the frames. Okay, along with this we will also create a save video function to save our output video. So we just write define save video. The input to this function will be output video frames, and along with this we'll also define the output video path. Okay, and we'll just write for cc. So we will just want to save our output video into this. We'll start save the output video in this format. Okay, and I will just write out is equal to cv2 dot video writer. I will just pass the output video path. We'll define for cc, and in each second we will process 24 frames, and over here we'll just write output video frames 0 dot shape 1, and we'll just write output video frames 0 dot shape 0. So we have just defined the width and the height over here for the output video. Then we write for frame in output video frames. We'll just write out dot write frame, and then we'll just write out dot release. Okay, so that looks quite good. Okay, so we have created a read video function, and we have also created a save video function as well. Okay, so now I will just go to the main.py file. Okay, so if you want to access these two functions outside this utils directory, then we just need to create an init.py file, and inside this I will just write from dot video utils import read videos save video function. Okay, and then I will just go to main.py file, and here I will just import all the required libraries over here, and I will write from utils import read video and also save video function. Then I will just create a main function over here, and I will just write, first we just need to read the video, so we'll just write video frames is equal to read video, and we'll pass the input video path. So we have the video.mp4, and then we just want to save video, so I will just write because to call the save video function, we'll just pass the output video frames over here. Oh no, so we'll just pass the video frames over here, and I will just pass create another directory by the name output videos over here, and inside this directory we'll just save our AVI file, output file. Then I will just write a so I will just write, then we'll just call this main function, and now everything is ready. Okay, so now we'll just run this python main.py file. Okay, so the processing, so this will just read the input video and save the video. Okay, so this will only do this one thing. So this will take few more seconds. So let's wait for this to finish. So we have our output being saved, but it's still processing frames. So this will take some time. So we just want to reformat our output. We want to create circles below each object, below each player, and we also want to create a triangle above the football as well. Okay. So it's still processing. This will take a few more seconds. So we have saved our input video. So let's see how it looks like. So I will just open the directory. So here you can see we have our output videos, and let me just play it now. So now you can see over here, we are able to read the input video and we are able to save the output video as well. Like you can see over here, we are able to read the input video and we are able to save the output video, and that works. Okay. So now we'll just go ahead and I will just create a new directory over here by the name trackers. And inside this directory, I will just create a new file by the name tracker.py file. Okay, so let's start writing down the code. So first of all, we will import all the required libraries. Okay, so we'll import OpenCV Python. We will import OS library. We will import NumPy library, and we will import pickle. So so from Ultralytics, we will import YOLO, and we will also be using supervision package. As I told you that we will creating circles below each player, and we will also be creating a triangle above the football as well. So we basically want to create this type of output. Mm, so as I told you that we want to have this kind of output. So we want circles below each player like this, and we also want to have circle uh, above the football as well. Okay, so for this we need to have supervision package. So we have already installed this package at the start. So now we'll just import this, and this is all. Plus, we also need to have, but we'll do this later on. So now I'll just write class tracker. I will just write in it. Okay. Okay. So we have the model path defined over here as well. So we'll just write self.model is equal to YOLO, and we'll just pass the model path over here. We'll also define the tracker, self.tracker is equal to, and we will using the byte track. So we'll just define the byte track. So first of all, I will just create a function by the name define detect frames over here, and the input to this function will be the frames. Okay. Uh, we will process 20 frames at a time. Okay, so I will just define a batch size of 20, and I will save our detections in this and in this list. So we'll just create an empty list. So I will just write for I in range 0 to length frames. Then we'll just pass the batch size over here. Then we have the detection batch. is equal to self dot model dot predict, and over here we will just uh, we'll process 20 frames at a time, so we'll just write frames. Okay, and we'll just write this, and we'll just define the confidence score as 0.1. Okay, and we'll just write detections plus is equal to detection batch, and this function will return the detections. Okay, so that looks good. Then we will also, after performing detections, we also need to perform object tracking, and for object tracking we will use bytrack that is provided by the supervision. Okay, so we can do over here is we just create another function by the name get object tracks. Okay, and the input this function will the frames. Okay, and so this is what we have. Then we'll just write detections is equal to self dot detect frames, and we'll just pass the frames over here. Then uh, one thing I just okay, so we can just write before we just go ahead. I will just write for frame number comma detection in enumerate detections. Okay, so then I will just write class names is equal to detection dot names. Okay, so plus what I want to do is I don't want to differentiate between the goalkeeper and player, so I just want to consider goalkeeper as the player. So I don't want to differentiate between the goalkeeper and player. I just want to consider goalkeeper as the player. So for this I just need to so basically the class names is a dictionary. Like in this dictionary we have like this. So I will just add comment. So this is like this dictionary. So this is our class names. In the zero, we have the football. Then at one, we have this goalkeeper. Even if I just have this over here, let me just reconnect. If I have the data set over here, I can just show you as well. Okay, if I just download this data set now, so this will take few seconds. So it's downloading the data set from RoboFlow. Okay. So if I just open the data.yml file over here, so you can see that first we have the ball, then we have goalkeeper, then at third we have player, and at four we have the referee. Okay. So we have at first we have the goalkeeper, and then second we have the player, and at third we have the referee. Okay. So I will just reverse this. So now what we'll do is that I will just write v in class names dot items. So now I will just reverse this dictionary. So now I will have this like this. So now we have the goalkeeper, and now we have the player over here, and we have the referee over here. This is how it works. Okay. So now we also want to convert our detections into supervision format as well. So we'll just convert our detections to supervision detection format. Okay, so I will just write detection as supervision is equal to sv dot detections dot from dash analytics, and we'll just convert our detections into supervision detection format. Plus, we don't want to differentiate between the goalkeeper and player, so we'll just convert the goalkeeper to player object as well. So we'll just convert goalkeeper to player object. Okay, so we'll just write for object in, and then we have the class ID in enumerate. Then we'll just write detection dash supervision dot class ID. Okay, and we just write if class names class ID is equal to goalkeeper, then you just write detection supervision dot class ID. Then we have this and we have this, and so we are just converting goalkeeper to player object. Okay, then now we'll track the objects as well. So we'll just write detection with track. So I'll just write self dot tracker dot update with detections, and then we have detection dash supervision. Okay, so now what we have will do is I will just make do few things over here. Okay, so I will just write tracks is equal to, I'll just write players. So this will be an empty list. Then we have referees. Then we have ball. Okay, so now we'll just write tracks, and here we'll just write players dot append. We have an empty dictionary. Then we just write tracks. Then we have referees. So dot append. Okay, then we have tracks. Then we have ball. Then we just append. Okay, so now I will just write over here for frame detection in detection with tracks. Okay, then let's write bounding box is equal to frame detection 0 dot to list. So this will contain the bounding box coordinates. Then we have the class ID at index 3. So I will just write class ID is equal to frame detection 3. Then we have the track ID at index 4. So we'll just write detection 4. Okay. So now what we'll write is if class ID is equal to class name inverse. So if this, then then we have the then we have players. Okay, then we'll just write frame number. Then we have the track ID is equal to bounding box. Okay, and if we have class ID is equal to class names inverse, and if we have the referee, then just write tracks referees. Then we have the frame number, and then we have the track ID is equal to, okay. Then we'll just write for frame detection in detection supervision. Then we'll just write frame detection 0 dot tools. Now we have the class ID is equal to frame detection 3. Then we'll say if class ID is equal to class names inverse is equal to all, then we'll just write tracks ball. Then we'll just write the frame number over here, and then we have this. So here we'll have the bounding box coordinates saved over here. Okay. Then what we'll do is we just want to draw a circle below each player. Plus, we also want to save the outputs of these frames in a pickle format. So we'll just write read from we'll write read from stub is equal to pause, and now we'll also define the stub path is equal to okay. So we just want to save the output of these frames in a pickle format. I will just write if read from stub and stub path is not none and os dot path dot exists stub path, then we'll just write with open stub path. We'll just read this as f, and we'll just write tracks is equal to pickle dot load, and we'll just return tracks. Okay, and now I'll just go below down over here. If stub path is not none, then I will just write with open stub path. We'll just write as f. I will just write pickle dot dump tracks, and this will return tracks. Okay, so that looks fine. So now we just want to create a circle below each player. So we'll just use create another function by the name ellipse, and we'll use the OpenCV Python ellipse function as well. So I have already have written the code, so I'll just add this over here. Okay, and we also want to create triangle above the football as well, or the ball as well. So I will just add this function. Okay. So let's see what error we are getting. So let me just check out these errors. Frame. So there were few indentation issues, so I just fixed them. So now I've just we have written the code for the function draw ellipse. Uh, here you can see that we are using OpenCV Python ellipse function. So this basically create a circle below each player. Okay. Over here we have done all written all this code, and we are also adding the track IDs as well. So now we have created another function draw by the name draw triangle, so that we can create a triangle above the ball or the football. And here we have just used the draw contours function in OpenCV Python. Okay, so the center will be filled with the color green. Like I will just use the color green, like you can see over here. Uh, for the ball, we are just using the color green for the triangle, and the outer edges of the triangle will have the color black, as you can see over here, and the thickness will be 2, and the triangle with green color will be filled, like we have used cv2 dot filled. Okay, so now we are just calling the draw ellipse function over here for the player and the referee, and for the football, we are just calling a draw triangle function, and the triangle function will have the color green over here, and the player will have the player circle will have the color red, and the referee circle will have the color yellow. Okay, so we have done with this code. So now we just need to go uh, towards. So now we are just saving our tracking results in a pickle format, so that whenever we run the video, we don't have to wait for the processing on the video to get complete. Okay, so let's go to the main.py file and just call this function. So in order to access the functions that we have created in the tracker.py, we just outside this trackers directory, we just need to create an init.py file, so that we can access all the functions that we have created in the tracker.py file. So to access the functions that we have created in the tracker.py file outside the trackers directory, we just need to create an init.py file, and here I will just write from tracker import tracker. Okay, and here I'll just write from trackers import tracker, and here first I will initialize tracker. So I will just write tracker is equal to tracker, and here I will just pass the best model weight. So I'll just write model best pt, and here I will just write tracks is equal to tracker dot get object tracks, and inside this I will just pass the video frames as input, and initially we'll set the read from stub is equal to false. Then I will just pass the stub path over here. So I will just create another directory by the name tracker stubs. Okay, and here I will just write tracker stubs, and here we'll just pass player detection from pickup. Okay, so now I just want to draw output track, so I will just write draw output. So I'll just write draw object tracks. So we'll just write output video frames is equal to tracker, Let me just fix this up. This should be tracks. Okay, and then I will just call the draw annotation function we have created previously, and the input to this function will be the video frames and the tracks. Okay, and from here we'll take output video frames and pass over here. Okay, so let's start processing this video file. So now you can see that we are just using get object track. So this will return me the uh, tracking information for the player, referee, and the ball. We are just saving the bounding box coordinates for the players in each frame into this tracks, and then we are just saving that in a pickle format. So we are just saving the output of these frames, which are the bounding box coordinates, in a pickle format. Okay, so we have just created an empty dictionary for the player, referee, and ball, and in that dictionary we are just saving the bounding box coordinates, the frame numbers, and the tracking ID, okay, for each of the layer. Okay, so and then we are just saving this information in a pickle format as well. Okay, so that looks good. Now I'll just run the main.py file. Here we are just getting the uh, tracking information, like we are just getting the tracking ID for each of the player, and with respect to each tracking ID we are just saving the bounding box coordinates for each frame. Okay, and then we are just drawing the annotations, like we are just drawing a circle below each player, and we are just drawing a triangle above the football as well. Okay, so let's run this main by file, and we are processing the video frames in a batch of 20, like I told you that we will be processing video frames in a batch of 20. You can just change this batch size as well. So, okay, so, okay, one thing is that in the draw ellipse, we have just called this two function to calculate the center coordinate of the bounding box and to calculate the width of the bounding box. So I have not created this function. So I will just go over here in the utils, and here I will just create another file podcast utils. Okay, so we just write get center of bounding box. So get rid of center coordinates of the bounding box. You can just write return in x1 plus x2 divided by 2. And then we'll int 2 divided by 2. So this will give me the center coordinates of the bounding box. We also want to calculate the bounding box width as well. Okay, so that looks good. So we'll just write from, okay, no, we just want to open this init.py file, and I will just write from dot box utils import get center and get video width. Okay, okay. So let's run this main.py file now. I think there is still a mistake. I just, okay, I have imported this. That looks good. Okay, that looks fine. So now the processing on this input video has started. Okay. So this will take some time. Okay. So let's wait for the processing to get finished. So the processing is currently in process, and you can see that it's processing currently 20 frames at a time. So it's processing around 20 frames at a time. So you can see that we have set the batch size as 20. So it processes 20 frames at a time, and currently it's still in progress. So let's wait for the processing on this input video to get finished, and then I will show you the output video. So the processing on the video has been completed, and let me show you the output video. So I will just go over here in the output videos, and here is our output video, or let me just play it now. So this will take few seconds. So here is our output video. You can see that we are able to draw circles below each of the player, and we are able to assign a unique ID to each of the detected object. Plus, we are able to differentiate between the player and the referee. Like you can see that a yellow circle is being drawn below the referee. Plus, you can see that we are able to draw a green triangle above the football over here as well. And you can see that we are able to detect a football in almost all the frames. Using pre-trained YOLO11 model, we were rarely able to detect the football, but after fine-tuning the model on a custom data set, we are able to detect the football as well. And we are also able to differentiate between the referee and the player. And you can see that we have assigned a unique ID to each of the player as well, like 16, 11, 15, 19, 4, 9, 3, 1, 67. So each player is being assigned a unique ID. Okay. So that's all from this tutorial. In this tutorial, we have created a football analysis system where we are detecting and tracking the players, and we are also detecting the referee, and we are also detecting the football as well. So that's all from this tutorial. Thank you for watching.